as if they were moving in circular patterns on land, something impossible for 300-meter-long ships, especially when they were actually at sea. After several days, analysts began to understand what was happening. Iranian drones and missile strikes were reportedly taking place in the region, and the GPS systems there were likely being altered. However, no military has officially confirmed this. Iranian Shah drones in particular rely heavily on GPS coordinates. If GPS signals in a region are manipulated, their targets can easily be missed. Over the past several days, such unusual GPS behavior has been reported not only in the UAE but also in Qatar, Saudi Arabia, and across much of the Middle East. This raises an important question: how can GPS signals actually be altered? Many people find it difficult to believe that this is even possible. To understand this, we need to look at two separate concepts: GPS jamming and GPS spoofing. Seeing an incorrect location on a mobile phone might seem like a minor issue, but the potential consequences can be extremely serious. Before discussing the technical details, it is important to understand how GPS works. GPS, which stands for Global Positioning System, was originally developed in 1973 by the United States Department of Defense as a military project. The first GPS satellite was launched in 1978, and the full system became operational in 1995. Initially, the system was designed exclusively for military use. However, in 1983, after a Korean passenger aircraft was shot down due to navigation errors, the United States decided to make GPS available for civilian use worldwide. GPS works on a principle known as trilateration. In simple terms, satellites orbiting the Earth send radio signals containing extremely precise time information. When a mobile device receives these signals, it performs calculations to determine how long the signal took to reach it. Since radio signals travel at the speed of light, the device can calculate how far away the satellite is. For example, if a signal was sent at exactly 1:00 p.m. and reached the device 70 milliseconds later, it means the satellite is approximately 21,000 kilometers away. However, this only tells us the distance, not the exact position. Based on this distance, an imaginary circle is formed around the satellite. The device could be located anywhere along the edge of that circle, which can cover several countries. To determine a precise location, the device must receive signals from multiple satellites. When signals from a second satellite are received, another circle is formed, intersecting the first circle at 2 points. This means the device must be at one of those 2 points, but the exact position is still uncertain. When a third satellite signal is added, a third circle is formed. The point where all 3 circles intersect reveals the exact location of the device. The more satellite signals the device receives, the more accurate the location becomes.